Hello, everyone. Hi, my name is Matty Kadosh. I'm from Mellanox, and I'm going to talk about SONiC Plus. Or the other name, SONiC extension. So in the previous talk, we talked about data plan programmability and ability to customize the data plan. And I want to look at that in a higher level, because the purpose is actually not to customize the data plan. The motivation here is actually to come up with a new application or a new functionality that you want to run on your system. So let's see, what does it mean? So what we have up till now from SONiC, we have very solid, using the wonderful help of this community, we come up with a very solid NOS. We can run BGP on it. We have a very nice telemetry framework. We can do warm boot. We will have MLAG within a release or so, which is cool. But we want more than that. The reason we want more than that, because we think that SONiC is a great baseline NOS, but we would like to be able to add functionality to this baseline NOS without modifying the full NOS, without modifying the build system, without modifying the existing code, making environment for companies to actually provide microservices, services that from their, they won't need to actually develop a full NOS. They can come up with a use case and provide a solution for that use case. Whether those vendors are commercial vendors or Microsoft that have a specific uses, specific problem in their data center, and that want to solve it. So what are the requirements for such a framework? So first, we wanted to use the SONiC infrastructure. We don't want to come up with something which will run, we want to use all the goodies that we have. We want to use the Redis DB, we want to use the SII if possible, and it is possible. We want to use the persistent out there and everything, all the goodies the SONiC provide us, warm boot and so on. We wanted to be containerized because we wanted to be isolated from the rest of the NOS, which is a very good concept. And so let's talk about a few use cases for such an application. Just to mention, all those use cases are things that we are working on with customers and partners. So if you are interested in one of them, you can actually catch me later after the talk, and we can talk in details. So the first use case is load balancer. And again, so those are just an example. You can think of your own extension as well. So let's talk about load balancer for a moment. So load balancer, when I'm saying load balancer, I'm referring to stateful, and actually a stateful load balancer. And the motivation here is, if you look at data center, whether every data center have load balancing service, whether this load balancing service is accessing to Exchange server, when you access Bing, or when you are running Kubernetes and deploying the service. So one of the ingredients that you get is a load balancer that actually choose the real physical machine, or physical. When I'm saying physical machine, it's not necessarily a physical machine, but the entity that actually get the request and act as a server. Usually those boxes or the number of flows or number of entities that you need to handle are very big, and the functionality is different than a traditional box. So this is one cool extension that, if possible, we would like to come up with a container that will be the load balancing container, and apply it and deploy it in somewhere in the network. We can deploy it in the Tor, we can deploy it in the spine, or on the edge of the network. It depends on the use case. But imagine that if I, for example, trying to deploy a Kubernetes environment with a service that's called A, and instead of implementing the load balancer inside one of my machine, I can actually deploy this load balancer in the Tor which will save me a lot of compute power and increase my, my bandwidth as well. So I get something for free, actually. One other use case, actually, it was, again, this is the tunnel, VXLAN one. Prince talked about that, and Arkady talked about that as well. So it's the same VXLAN tunnel. This is yet another SONiC Plus or SONiC extension, and the idea is that instead of using the legacy VXLAN, the legacy layer 2 VXLAN that is out there and available, here we choose to use layer 3 VXLAN, and not only that, we wanted to actually create something that's called VNet, which is kind of a VRF, and a peering, which is the ability to leak or to talk between different VRF. So in the traditional environment, the way to implement that is actually duplicating around from one VNet to another, which is not scalable and not predictable, because you actually cannot anticipate how many route entry you will have in the system. Using flexible or SONiC extension, we can actually come up with a better scheme in which we are changing the routing table in a way that instead of matching on a VRF, we can match on kind of a vector. And by doing that, we can actually increase the scale and have, instead of duplicating route, we will have a single route per entry out there, per VM entry out there, regardless of the peering sessions. This is another initiative we're working with partners, security extension. And this is actually being able to monitor layer 1. To monitor layer 1, sorry, and detect tap or malicious attacks in a layer 1 level. And again, the idea is quite the same. Run a Docker container with the logic, apply it on SONiC, don't touch the rest of the logic out there. And the last example is telemetry. If you're on this stage, you must talk about telemetry. So I will talk about telemetry as well. So when we are saying telemetry, it's like in opposed to BGP, which is well defined. There are a lot of ways to do telemetry. So we want to make it flexible and keep it flexible. So this is one initiative that we are working with partners. And the idea is to actually being able to match on a flow and a marker. And marker can be very simple, like a bit, DSCP bit, or it can be very complex. It can be a very complex condition, something that is bigger than something if the sequence number is bigger than 4 or whatever. We want to keep it very simple. And if we saw this marker, we want to actually send the packet like the postcard-based telemetry, send the packet internally to some collector, some agent, some telemetry agent that will sit internally in the box. The reason we want to do it that way is we want to actually reduce load from the controller. We don't want to stream all those packets to the controller. We want to actually summarize them in the local agent and then send some summarization to the controller. So thing that you can collect is for such a flow can be like the obvious one will be ingress port, egress port, queue depth, latency, number of packets, number of drop packet, and so on, and the reason the packet were dropped. And by doing that, we can actually provide a very good visibility into a network but in the same time, reduce the load from the collector. Okay, so those are nice stories about use cases. So why we are talking about that? What is missing? So we heard today that SONiC is containerized environment. So what is the problem? Please deploy your own container. Everything is working. What is missing? So in order to understand what is missing, let's first describe in very high level, and forgive me for all the guys that are familiar with the way that SONiC architecture look like. I just want to make sure that everybody in the room are aligned. So, and again, it is a very high level description of how SONiC architecture look like. So we have application in SONiC in general. Application is configure some entry in appdb. As a result, some module inside the org agent will take this configuration and translate it if needed into ASIC-DB entry. And then syncd container will take this ASIC-DB configuration and will apply it via SI into the ASIC. So this is in very high level how SONiC look like. Okay, so let's see what is missing or what we have. So what are the components, sorry, that help us create this extension? So the first upper one is the application. So next one is the being able. So we may when we are coming in and we want to introduce a new functionality, we may need to come up with a new application. Cool. Second stage is after we wrote a new application, it may affect the way we want to configure the silicon. As a result, we need to modify or enhance the org agent as well. By doing that, we may need to, since it may require some new ASIC configuration, so we may need to extend and modify syncd as well. And if we did that, we may need to extend SI as well. Okay, so the color coding here is green is supported, and what is that? Orange. In my computer, the color is a little bit different, but never mind. And orange is not supported, and I will show why. So first, let's talk about the good stuff, the green one. So the green one application it's quite easy. Actually, it's the easiest part. So we can run a new application, user application on top of appdb. Actually, it is not really supported. There is a very small piece in the puzzle that is missing, which is the SWSS API that currently are not exposed as part of the build. This is a small change that we can do in order to make that, support that and actually enable user to run their own application on top of appdb. So I consider that as done and green. Let's move to the next one. Next one is a bit more complicated. And it is the ability to actually customize or extend the data plane itself. But it is not enough to extend the data plane. We need to actually extend the SI API as well. So because the reason for that is that you could actually, working in an hybrid mode, when I'm saying hybrid mode, I'm referring to different layer of hardware API, SII in one place comparing to vendor SDK or whatever it will be on the other end will create a problem, because then you won't be able to share object between one and another. And that means that actually you cannot really extend it without the need to rewrite all your program from scratch. So as a result, what we created, and it is actually upstream in SI for, I think, a few months already, we created a framework that can take a programming language, we chose before, but any programming language will work. So we take a user program, we inject it to some point in the pipeline. As part of the program, there are we define the point in which you want to inject the program. We are using P416 for that. And as a result, the backend curve and actually create the piece in the pipeline within the silicon, but in addition to that, we auto-generate SII API. So what we get out of it, we get a single layer of API, which include all functionality, all the legacy SI code, but in addition to that, it includes the new functionality that you just created. So this is done and working. Sorry. Okay. So let's see how it looks like when we have those two pieces, whether those two pieces are enough to add a user functionality to SONiC, sorry. So now we add some user pipeline. As a result, we have the auto-generated SI API, cool. We extend the pipeline itself, cool. We wrote the application that can work on the new pipeline, cool as well. But then we need to do that. We need to patch orc agent, and we need to patch syncd in order to introduce the new functionality to those two entities. And this is not ideal, because you cannot take actually a SONiC and an upstream SONiC and add your container into it. You need to modify the upstream SONiC in order to be able to do that. And we think we need to do it. We need to do better than that. So this is what we actually want to achieve. We want to be able to do the same for orc and sync. We want to be able to actually extend sync and extend orc agent by adding a new module to orc agent or adding a new functionality to syncd. It's not really running in additional syncd or running additional orc agent Docker. This wasn't the intention of this slide. The intention was that we want to actually extend syncd and extend orc agent without the need to modify the legacy ones, the one that we took from the SONiC. So how can we do that? So just to mention, this is just a proposal. We didn't work on that yet. We are planning to, but this is just a proposal. We can, so it is in early stage. I will be glad to get your feedback on those extensions and modify them if needed. So let's see how we can solve the syncd problem. So in syncd, what we can do is actually extend RPC in runtime. Relatively easy to achieve. And in addition to that, we can load the new functionality. We can dynamically load the new functionality that was created by the compiler, by the compiler that generates SI into syncd. And by doing that, actually, we can extend the existing syncd and add the new extension into it. And for orc, it will be a little bit more tricky. Something I didn't mention, actually, let me go back. The reason there is a green below the blue here, maybe it should be on top, is that now my green code actually can use some object from the blue one because they are sitting in the same process. And it is important because when we are talking about extension, we understand that extension, in most cases, will want to use some legacy object that was created by the legacy SONiC. So we want to do the same to work. And here, it will be a little bit more difficult. And maybe I will give an example to explain the problem. So we can run easily a new module inside orc. Easy to achieve. This module can register to appdb changes and can, as a result, configure asicdb, easy to do. But the problem is, let's talk, even I will give a very simple example. So let's talk about just the flow, the telemetry. I want to program a rule, which will be a programmable rule, which we extend. We have auto-generated API, so cool. We have the ability to configure it. But I don't want to, and as a result from this rule, when this rule hit, I want to mirror the packet to the CPU. But I don't want to create the mirror session and all the mirror configuration in my orc. It exists already in SONiC. It exists already inside. So I want to use the legacy SONiC configuration, the one that already exists, and actually point for my rule to a a session that's created by SONiC. So my OC agent need to understand which session you need to configure, you need to point on when someone create a rule. So in order to do that, what we suggest to do is actually add an object ID, a handler, for each appDB entry to the corresponding ASIC-DB entry. So there may be cases in which single app will point to multiple ASIC-DB, or one-to-one, or one-to-none. There will be app that does not relate to any ASIC-DB entries, which is fine. But by doing that, actually, my agent now can understand the correlation between the session, the app session, and understand what is the corresponding ASIC entry, ASIC-DB entry, and as a result, it can actually configure it and point from the newly extended rule to the new, and point to that rule, and add an action to that rule to point to the new, to the existing session ID that it won't use. I guess. Okay. And finally, so as I mentioned, this is only initial step. It's really, we are really at the beginning. We have an idea, and we really think that it will be great if we can work together with the community to make it work and make SONiC extendable in a way that vendors can add their logic on top of it without the need to patch it and modify the main SONiC code. That is it.
Any questions for Maggie?
Hi, Maggie. One question. We're talking about the SI extension. So what about, say, if I want to extend SI for other chip vendors? So our software can be reused for all chip families or from other vendors. So how do you think about this?
So the SI extension are not vendor specific. The Flex SI layer is totally generic. It actually, if you look at the API generated, the API are correlated to the logical entity that you created as a user. So every vendor that will write a compiler that can actually support this table that you just created and program it into the hardware will be able to support the same APIs. So it is not a vendor specific, it is actually a vendor agnostic layer.
Okay, then my follow-up question for this, if this SI extension is kind of generic or vendor independent, why not just put into SI standard definition?
It is part of the SI standard.
It is already?
Yeah, it is there.
It will be, okay.
So the only thing that is not there is the backend, which of course is vendor specific. So the backend layer is the layer that actually programs the silicon. But the one that expose and auto-generate the SII API is out there. It is open source.
I see, got you, thank you.
Okay. Any other questions? No, let's thank Matty.